What's going on, everyone? You're back with your boy Jono for another quick math lesson. Today we're going to look at a concept called ratios, and this is our introductory lesson. So if you haven't heard about these before, please stick around and you might learn something new. So sometimes we want to compare two things that are similar. So a really good example is the like to dislike ratio on like a YouTube video or something like that. Another time you might hear the word ratio is on Twitter or TikTok when someone gets ratioed. This is where you've got more comments than likes, which means you've probably done something that's a little bit negative or that's stirred up some controversy. But what's really important for both of these is we're comparing the number of two things, likes to dislikes, comments to likes. And that's the foundation of ratios as a whole topic. This is actually the mathematical definition for a ratio. We are comparing the amount or the quantity of two things that are pretty similar. And if we've got that in our mind, we're going to find the rest of this lesson pretty easy. A comparison of two numbers. Ratios are also really helpful for when we scale up or scale down a project. So say if you've got a great recipe for 4 people and 10 people rock up to your house, ratios is how we know how much extra we need to cook. How much does the recipe need to increase to feed these extra 6 people? It's also really good for scale models. Say if I wanted to draw a map of Australia, I don't want to draw the whole thing to actual size. That would be the size of Australia. So we need to make a scale that shows everything to the right proportions, but on just one A4 piece of paper. So if we think about the like to dislike ratio on a post, for example, you might get 20 likes on a post and 1 dislike. And this is actually what ratios is all about. This would actually be enough information already, but we want to be lazy. We want to write the least amount of stuff possible. So instead of writing for every 20, 1 dislike, all of that, we've come up with a quick shortcut in order to show this. Anytime that we're comparing two things, so the term for every in this one, or you could hear part or to, instead of writing that every time, we just write a colon. The colon tells us all the information we need. It's saying, hey, we're comparing these two things. So instead of writing this whole sentence, all we've got to do is write 20 ... 1. And that says 20 to 1, or 20 of these for every one of these. And that's all we need to be able to do. The two numbers, the two quantities, compare them with a colon in the middle. Another example is if you've got to make a cup of Milo, and we're going to say it's 3 parts milk to 1 part Milo. So for this one, the 2 is going to be our colon. So instead of writing this whole sentence, all I've got to do is 3 : 1, and I'm done. And then there are heaps of visual examples that we can use as well. So here I've got 10 squares. 4 of them are blue and 6 of them are white. My ratio of blue squares to white squares is just 4 to 6. And again, I'm using the colon instead of writing a whole sentence. 4 : 6, done. Something that's really important with ratios is that the order absolutely 100% matters. So the ratio of blue squares to white squares is 4 to 6. But the ratio of white squares to blue squares is 6 to 4. And making sure that we're very specific with our language is essential to getting these ones correct. So whatever is stated in the question, you've got to be extra careful reading that so you can put your ratio the right way round. As we said at the start, scaling up or scaling down projects is really important with these ratios. So let's say this was a path or something like that, and these are the tiles that I've bought. What happens if I wanted to double my thing? So because my ratio is 4 to 6, all I have to do is multiply both of these by 2. I would then have 8 to 12. I'd need 8 blue squares and 12 white squares. So all we've got to make sure we're doing is the same operation times 2 on both sides. Now the opposite way, if I wanted to make something that was half as big, again, I would just have to do the same operation, divide by 2 on both sides. So 4 to 6 would become 2 to 3. This is actually really important because this is the simplified ratio, just like in simplifying fractions. This is a skill that we're definitely going to work on for the next lesson, but all we really need to know is that if we multiply and divide a ratio, as long as we do it to both sides, the whole thing stays the same, just bigger or smaller. Thanks so much for watching this lesson, and I'll see you later.